Thank you, Dyndrite, for organizing this event and also having me over here to speak. And also thank you to our speakers already spoke, Renisha, HP, the great things that you guys are doing in response to the COVID crisis. It's a great job. Great to see that the additive manufacturing community is pulling together in these tough times. I think we saw an article recently on LinkedIn about the renaissance of additive manufacturing. It's funny and ironical since it's such a new technology, but hopefully we'll have good things coming out of this. With Ansys, and I'm going to talk a little bit about Ansys and then talk about our additive solutions, just keeping a track of time over here. Those of you who don't know what Ansys is, we are a global leader in simulation. Our mission is to empower our customers to design and deliver transformational products. And how do we do that? We have simulation technology for that. We are the market leader across individual physics with an industry-leading platform. And with over 45,000 customers and 4,000 employees spread out over 75 offices, we have quite a large user base, if you will, in the simulation world. We have what we call a platform solution, where which is called Workbench. The new platform that we're developing is also called Discovery. And on that, we have built a materials information platform, and which allows us to do and conduct simulations in various physics, right? From the fluids, doing the CFD structures where the additive manufacturing solution sits, electromagnetics, semiconductors, optical simulations as well. For this year and in the next few years, the Ansys focus has been and will be on a couple of major pillars, if you will. One of them is autonomous. Second one is electrification. Third one is digital transformation. And that's where the additive manufacturing solutions plays an important role. We have world-class companies leveraging our platform. It's interesting statistic, over 97 out of the 100 top 100 companies in the world use Ansys, all the way from aerospace to industrial companies, phones, and electronics manufacturers, especially in the 5G arena, are using Ansys solutions a lot to understand the effects of 5G waves and wavelengths and how they can create products which can work really well with them. Automotive, obviously, oil and gas, which of course is a debatable scenario right now, seeing where things are going. A lot of the home goods, consumer industries, and also a big chunk of the healthcare companies use Ansys platforms. So let's jump into the additive solutions. That's what we are here to discuss. At Ansys, what we have created is a comprehensive and scalable solution to minimize the risk of your additive manufacturing process, right? With every additive manufacturing process, the reason we haven't seen the adoption that we wanted to see is that there's still a lot of risk. There's less repeatability in the process. So we started with the process simulation, but quickly realized that our customers require more of an end-to-end solution to actually make sure that their additive manufacturing supply chain or the process is successful, right? Starting with design for AM through build setup, of course, process simulation, which is our bread and butter, material analysis, data capture, and all the way through part qualification. And I'll jump into the functionalities of all of these in a bit more detail over here. So we are not a CAD company. Like I mentioned, we are a simulation company, but we do partner with a lot of CAD providers, right? From Autodesk to PTC, all of them are really close partners for Ansys. When we say CAD modeling, what we are referring to is more about creating the files which are suitable for additive manufacturing, repairing the facets, doing topology optimization, lightweighting, latticing, and the likes of it. Moving into the build setup area, this was born, I would say, out of complete customer feedback. People had the design for AM tools from Ansys, and they had the process simulation tools, and they didn't want to jump into other tools just for creating the build files. So we had this tool launched about 6 months back. This is limited to Powder Bed Fusion only as of right now. The process simulation Again, limited to powder bed fusion and DED, so metal AM technologies. Right, as of right now, we are working actively on other technologies, other manufacturing technologies as well. Material analysis, that's our additive science tool, which went full release only in January of this year. It was in beta form earlier. And this is geared towards more advanced metal AM users where they can dive deeper into the microstructure levels. Data acquisition management and part qualification, those are basically coming from our grant acquisition that we made earlier this year. So just give you a brief background on how fast we have been moving and the Ansys dedication, if you will, towards additive manufacturing. We acquired a company called 3D Sim early in 2018. And this was what our portfolio in additive looked like at FormNext of 2018. And in just 1 year at FormNext 2019, the one where I met a lot of you people on the line over here, we expanded our portfolio to include all these different tools, right? Like I was saying, from design firm all the way through qualification. This has basically given our customers the entire tool set within one software environment, right? So just diving a bit deeper, being cognizant of time, I'll not let the animations roll through. We have two different ways of design for AM or topology optimization inside of Ansys, again, through two different platforms, which I was mentioning earlier. One is through our discovery platform, which is more of a GPU-driven, graphical-based interface. The other one is through our Workbench platform, which is a much more simulation-driven, where people who are more accustomed to the FEA world can create scripts and create the topologically optimized part. So we're not trying to discount any kind of users, and we want to cater to both the users. The idea that we had over here is with the additive manufacturing world, it's much more of a younger crowd which is coming in. There's a lot of design engineers, which is not technically or traditionally, it has not been the Ansys target customer, right? What we are trying to do over here is target even the designer level engineers who are trying to get into the additive manufacturing space. For our build setup tool, as I was mentioning, this is for a metal powder bed fusion. What I really like about this tool is it's very intuitive. As you can see, I don't know if you can see my cursor over here, but the heat maps, which really provide anyone to create the right build orientation. One of my first job experiences was from the service bureau, and I really know the pains of finding the right orientation. It takes a lot of trial and error, a lot of practice. So what we have over here in the heat maps is you can either have the least amount of supports, you can either prioritize your build speed, or you can have your distortion tendencies, and you can give your weightage accordingly. By default, obviously, it's set to the center and it automatically finds the right orientation, but you can drag depending on whether you are in a nick of time and you're trying to build a part in the fastest way, or if you want the least amount of supports and make it more cost effective. In the latest release, we are also adding a heat map on the cost. Of course, that is, again, a little bit of a perspective thing. It helps if you're making a large number of similar parts versus a lot of different parts and things like that. Process simulation, this is where everything started. Basically, what we are trying to do with process simulation is predict any kinds of build failures, which and ensure your metal parts coming out first time right? We can predict blade crash, we can determine any stress and strain accumulations, how the part would behave when you remove from the build plate, what kind of effects and distortion are there in your metal parts before and after cutoff from the build plate. So all of these essentially help you make sure that you remove the guesswork out of your process and is ensuring that your parts are coming out first time right. Material analysis, again, a very new tool that we have going into the micro level capabilities, predicting the porosity, your microstructure, grain size, how it's oriented, how your melt pool looks. These are of really interest to metallurgists and AM specialists who are diving deeper and want to know how their parts will behave once they're out of the printer. And this also helps in the part qualification a lot. Which brings me to our last point with our data capture management and part qualification with Granta, which has the databases for all around the world. They also have a tool called Granta MI, where all the information right from your design stage through build simulations, your material manufacturer, your OEM, your build log, everything gets accumulated and it automatically spits out a certification report for your aerospace standards, for your healthcare or medical standards and as such. So essentially completing your chain of events, right? And running about 4 minutes over here, just quickly sharing our roadmap, where we are headed. We have partnered with X1 and we are creating a binder jetting simulation as well, especially on the sintering side. We are seeing a lot of interest from our customers over there. We continue to add a lot of partners. Renisha, who just spoke earlier, Trump, Additive Industries, we are already partners with EOS and SLM. We need to work really close if we want to get accurate simulations and also ensure that these machine manufacturers and their customers are satisfied with the quality of prints, right? We're also working closely on predicting FDM simulations and other polymer simulations, but that's still down the line for us. And how are we doing this? We're working with a lot of partners, including Dyndrite and a lot of others in Europe, in US, and in Asia. So thank you all if you guys are on the line. And with that, I would like to take any questions if there are.
All right, thank you, Nilay. That's some exciting news with X1 you've got going. First question, could you speak more about the melt pool dynamics prediction capability from Ansys?
Of course, yeah. Are you still seeing my screen?
Yes.
Perfect. So what we're trying to do over here is we take a cubic meter, a cubic centimeter of the area, and then we're diving deep into the microstructure over there, and then we're extrapolating these results for the entire part, right? We cannot do a microscale level simulation for the entire part. It's possible, but it would take us weeks and weeks to do it. So right now it's basically being predicted on a really small cross-section of the metal part. But what we are also doing over here is taking information from the metal OEMs directly from the material manufacturers and taking all these data and then outputting the results.
All right, thank you, Nilay. From Dylan, does Ansys have on the roadmap a closed loop dimensional optimization workflow designed for additive manufacturing to print, scan, calculate, anesotropic predistortion, modified design data, or process input and repeat?
So closed loop control would be the dream. That's where we are headed. And I think that's where a lot of the manufacturers, metals, plastics, composites, anyone would like for us to go. That as soon as you have any kinds of irregularities, you can automatically correct, and then you can send it to your print. And for that, we're working closely with a lot of manufacturers. That's in the future, and it's not as easy as it sounds, but we're working towards it.